This is the lecture number 3, and in this lecture we will suggest the book for reading and give you some problems to solve. So let us start. The first book is the book of Ramji Lal, Algebra 1, Springer, 2017. Second book is J.A. Gallian, Contemporary Abstract Algebra, Narosa, New Delhi. New edition is also available. You can take that edition. I.N. Hurstein, Topics in Algebra. D.S. Dummett and R.M. Foote, Abstract Algebra. If you are the first reader, then you should go through these two books, 1 and 2. Means you are reading this group theory course first time, then you should take either Gallian or the book of Ramji Lal. If you are reading it in second time, then you can go through the I.N. Hurstein or Dummett and Foote. Now I am coming to the problems. Problem number 1. Let G be a set containing n elements. Find the number of commutative binary operations on G. What can one say about the number of associative binary operations on the set containing n elements? Problem number 2. In the following, determine the system describes R group or not. If they are not, point out which of the group axioms fails to hold. So first is G is the set of all integers and the operation is A dot B is equal to A minus B. Second is G is the set of all positive integers and the operation is the product of integers. Third is G is the set of all rational numbers with odd denominators and the operation is A dot B is equal to A plus B, the usual addition of rational numbers. This problem has been taken from the book of I.N. Hurstein. Define a binary operation O on Z by XOY is equal to mod of X minus Y so that this O is a commutative binary operation but it is not an associative binary operation. This question has been taken from the book of Ramji Lal. Next question. Let G be a group and X be a non-empty set. Let G to the power X denote the set of all maps from X to G. Define a binary operation star on G to the power X by F star G of X is equal to Fx OGX for all X in X so that Gx with respect to star is a group so that it is a commutative group if and only if G is itself a commutative group. This problem has been taken from the book of Ramji Lal. Let G1 O1 and G2 A2 be groups. Define a binary operation star on G1 cross G2 by AB star CD, where this A and B are the elements of G1 clearly and B and D are elements of G2 and the operation is coordinate wise. So A is composed with C because both are elements of G1, so the operation is of G1, and B is composed with D because both are elements of G2, so the operation is of G2. Now show that G1 cross G2 star is a group. This problem has been taken from the book of Ramji Lal, and actually G1 cross G2 is called the direct product of the group G1 and G2. Now next problem, problem number 6. Let G is equal to Q minus 1. This symbol means minus. So Q is the set of all rational numbers and I remove 1 from this set. So this is Q minus 1. Define a binary operation O on G by AOB is equal to A plus B minus AB, where plus and dot are the usual addition and multiplication of rational numbers so that G is a group. Now the question is, what is the identity and what is the inverse of an element A in a group G? So this question has also been taken from the book of Ramji Lal. Next, problem number 7. Let G be a group and X be a set, and suppose that F is a bijective map from X to G. Define a binary operation star on X by the requirement that F of X star Y is equal to Fx OFY so that X star is a group. So it means if G is a group and X is a set and there is a bijection between x and g, then we can define a binary operation on x such that x star will become a group. This problem has also been taken from the book of Ramjilal. Now problem number 8. Suppose x is a non-empty finite set so that we can always define a binary operation on x so that it become a group. Now problem number 9. Examine whether the set 1 plus 2m upon 1 plus 2n such that mn belongs to z of rational numbers forms a group with respect to multiplication of rational numbers. Okay. Now problem number 10. So that the set m by n such that m and n are integers, n is not equal to 0, and n and p has GCD 1. This symbol means n and p has GCD 1, and where p is a given prime number. So p is a fixed prime number. For that prime number, consider this set, and you have to show that this is a group with respect to addition of rational numbers. Now problem number 11. Let p be a positive prime and gp denote the set of all complex numbers which are p power roots of unity. Show that the multiplication of complex numbers induces a multiplication in gp with respect to which it is an abelian group. Now problem number 12. Let g is equal to a plus b under root 3 belongs to R such that ab belongs to Q. Prove that g is a group under addition of real numbers. Now problem number 13. Let g is equal to the set x in R such that x is greater than equal to 0 and less than 1, and for xy in G, let us define an operation star x star y to be the fractional part of x plus y. Fractional part means we will add x and y and subtract the greatest integer less than equal to x plus y. This is the greatest integer less than equal to x plus y. Now we have to prove that a star is a well-defined binary operation on G, and G is an abelian group under star, and this group is called the real number mod 1 group, and this problem has been taken from the book of D.S. Tammet and R.M. Forte. Now problem number 14. Let R star be the set of all real numbers except 0. Define a star on R star by A star B is equal to mod A into B. So the question is R star a group with respect to a star operation? This problem has been taken from the book of Ramjilal. Now problem number 15. Alpha beta belongs to R. Define a map phi alpha beta R to R by phi alpha beta of x is equal to alpha x plus beta. Let G is equal to phi alpha beta such that alpha beta belongs to R2. For fg in G, define composition f composed with G in G by f composed with G of x is equal to fx and G is applied on fx. Then which of the following statements are true? More than one statement may be true out of this 4. The binary operation O is associative. The binary operation O is commutative. C is for every alpha beta in R2 alpha not equal to 0 there exists a AB in R2 such that phi of alpha beta composed with phi of AB is equal to phi of 1 0. And GO is a group. So this problem has been taken from the question paper of JAM 2017, and this is a multiple select question. Now problem number 16. On R2 define a binary operation star as follows. For x, y, z and x dash, y dash, z t dash in R3. Define a operation x, y, t star x dash, y dash, t dash is equal to x plus x dash, y plus y dash, t plus t dash plus half of x dash y minus x y dash. Then show that R cube star is a group and define its center. There is a mistake. In place of this z there should be t, so you change it. This problem has been taken from the question paper of JAM 2011. So these were all the problems. Now I would like to suggest you two more books, and these are the book of Michael Artin, Algebra, PHI publication 1994. New edition may be available in the market, so you can see it. And one more book which is a very known book, the book of J.B. Freilich, A First Course in Abstract Algebra, Narosa Publishing House, New Delhi 2002. So these two are also good books, so you can keep it in your library. Okay, thank you very much.